Given the function f of xy equals 6 natural log 17xy plus y to the third, find the following functions. The first function is f of x2. Instead of y, there's the number 2. So in this equation, you replace the y's with the number 2. So f of x2, that's supposed to be a parenthesis, equals 6 natural log of 17x. Instead of y, I'll put the number 2 plus 2 to the third. So now what we'll do is just combine the like terms. So f of x2 equals 6 natural log of 34x plus 8. And that's it. That is f of x2 for the following function above. For the second equation, you have to find the derivative of f of x2. And because there's a function within the function, you have to apply the chain rule in order to find the derivative. So what I like to do at least, is substitute, because I find that's the easiest way to do the chain rule. So I will do f of a equals 6 natural log of a, but then for a of x, it would be the internal formula. So it would be 34x plus 8. And the chain rule goes as follows. It is f prime of a of x times a prime of x. So we're going to have to find the f prime and the a prime. So for f prime of a, the derivative would be 6 over a, because for the simple derivative of natural log, it is just 1 over x, and because that the 6 is in front, we would put the 6 on top because a simplified fraction. And then for a prime of x, it would be simply 34, because the derivative of 34x is just 34, and then the derivative of a is just, the derivative of 8 is just 0, because it's just a whole number, and the derivative of a whole number is 0, so that doesn't matter. Because we have f of a and f of a prime and a of x prime, we are able to now do the chain rule. So with f prime of a, it is 6 over a. So then the derivative would be d of f x2 over dx So instead of putting a back in there, we're going to put a of x. So that would be 34x plus 8, and then times a prime of x, and a prime of x is just 34. And then we're just going to simplify that equation, so then d f of x2 over d x would then equal 204 over 34x plus 8. So I just multiplied 6 by 34 because this is technically 34 over 1, so you can just multiply the 6 by the 34 to get 204. And then that is your answer for B. For the next equation, f3 of y, we are going to do the same thing that we did in A, but instead of replacing the y in the given function, we are going to replace x, because instead of having fxy, instead of x there's 3, which means x equals 3. So f of 3y equals 6 natural log of 17. And then instead of putting x, we're going to put the number 3y plus y to the third. And then like we did for this one, we're just going to combine the like terms. So in that case, it would be 17 and 3. So then the answer for f3 of y would equal 6 natural log. So like we did with here with combining the 2 in the set, like multiplying 17 and 2 to get 34, we're going to do the same, but with 17 and 3. So it would be f3 of y equals 6 natural log, and that is 51y plus y to the third. And then we're going to have to do the derivative for this equation again. So, and we're going to have to do the substitution method again for that. Well, I guess the chain rule by substitution, which I think is the easiest way to do it. So what I am going to do is f of a. It's the same as previously before because it's the outside function. So it would be 6 ln of a, which means the derivative of that would be f prime would equal 6 over a, same as before up here, because it's the same outside function. Now where it's different is with the inside function, because we do have a different inside function here versus here. So a of y equals 51y plus y to the third. So now we have to find the derivative of a of y. So a prime of y. The derivative of 51y is just 51, and then for y to the third, we do the power rule, so that would be 3y to the second. So now we have to apply the chain rule right there again. So we would do df 3y over d of y equals 6. Now instead of putting a, we would do the a of y, so that's 51y plus y to the third times, and then we're going to put the a prime of y, because a prime of, that's the next step in the chain rule. So that would be 51 plus 3y to the second. And then what we're going to do is just, since this is technically 51 plus 3y to the second over 1. We can just plop that right over there to where our answer would be df 3 to the y d of y equals 6 parentheses 51 plus 3y squared parenthesis all over 51 y plus y to the third. And that's how you get df of 3y over dy. And that's your answer. Have a great day.